Okay, cool. One more time, hello to each of you guys. I hope that you are all doing great. In the previous sessions in this unit, we learned a lot. We learned about Kali Linux, we learned about VirtualBox, we learned about some libraries that they are available for improving functionality in Python. In our tonight session, we just want to have a chat about software development life cycles, and then we will learn a little bit more about different methodologies we have in software development. First of all, let's to go down and have a look on the outline of this session. Just the usual information that you know about how to apply for an extensions and raising your hands if you have any questions. So what we want to do in this session, recognize and implementing secure coding practices to mitigate vulnerabilities. Tonight I will also have a look on our assessment task 2, which is a port scanner. And you see there are a couple of activities in the assessment task 2, which is asking to work on a pseudo and a pseudo chart, and also it's a start with a user story. So in our tonight class, we will have a chat about what is a user story and what is a pseudocode. In the previous unit, we learned about pseudo. It's just like putting all the steps to perform a task in our own language. We will work and we will talk more about pseudocode and how we are able to break down a whole big complex project into multiple small pieces. Writing pseudocode to plan security focused tasks, outlining the steps for tasks like monitoring unauthorized access attempts. Then we will also have a chat about SDLC or Software Development Life Cycle. In this presentation, we just will have a chat about waterfall and agile approach. There are so many other approaches in software development, so we will see what are the differences between these two and which approach is a better option for which scenarios, and also the applicability to scripting projects. We will also, as discussed, have a chat about user stories, the benefits of creating user stories with use cases. And also here you see an example of, as a network admin, I need an alert system for unusual traffic spikes. So this sentence is an example of creating user stories for what purpose, for what type of audience, and what might be the benefits of creating a software. So just by putting a user story like that, it will help us to write the code in a most efficient way. And also we will have a chat about the differences between user story and pseudocode. So that's the outline for our tonight session as you see in this presentation. Let's move on. Pseudo or pseudocode, as discussed before, it means an informal, high-level description of a script's logic used for planning purposes. It serves as a means of outlining the structure and step of a script before writing actual code. After having a look on this slide, I will go to my board and I explain the pseudo in more details. Also, I go to assessment task 2, and you see that it focuses a lot on pseudocodes and describing the application that we want to make in this unit. Pseudocode helps us to early identifications of potential issues and also to ensure the script is aligned with security objects. When drafting pseudocode, all security requirements should be considered from the outset. This block is so important. Later on, when we go to search for in cybersecurity, if you proceed to search for in cyber, we will see that now we have a new approach in cybersecurity. Previously, cybersecurity, it was like the last step in creating and maintaining a security system. So first of all, probably companies or entities, they already have an IT systems, they already have their PCs, they already have their servers, their networks. And when they had all the network built and set up, then the next step was how to secure this. But in the new approach, we will see it should be completely going from the other side. It's just like, for example, building a property in an earthquake potential zone. For example, imagine a country like Japan that almost every day they have an earthquake. So just like building a property, and when the property has built, then to go and check what we can do to make this property stronger. But in such country, in such environments that they have heaps of earthquakes in a year, obviously, before starting to build a property, they need to think about everything, to think about the layout, the material, everything to be strong enough to survive against an earthquake. It's the same in cybersecurity. before building an IT system, the first step should have a chat with cybersecurity experts just to make sure what type of layout probably is the best option for this type of customer, for this size of operation, what might be the structure, what might be the layout, what type of software probably we need to have, what type of hardware probably we need to have in order to have a secure system. So all of these things should be in the first step. And as you see here in this block, it says we just need to draft all security measures in our pseudocode. Imagine that you are creating an application. Before writing the code, not only we need to think about the functionality of the codes, but also we need to think about security of the code. I will give you more examples on what do I mean when I say when we are writing the code, we need to consider security measures in our coding. So when you bake security into the design and architecture, would reduce the risk of discovering a structural flaws. And that's completely true. As I said, when in the first step, we consider all security measures in our coding, it reduces the risk of discovering some problems or loopholes in our IT systems, like poorly designed authentications or flawed data validation. Instead, for in cybersecurity, we have one specific unit talking about data validations and website vulnerability, which is specifically focused on security of websites or web servers. Anyway, just keep this in mind and let me to switch my board and have a little bit more chat about the pseudocode. Also, before jumping to my board, let me reshare my screen or let me to just, yes, I should change my screen 2. You can also see more about the pseudocodes in our current unit. If I go down in ICT PRG 435, and if I have a look on assessment task 2, you see that it focused a lot on pseudocodes and writing down all the steps that we need to create a part scanner. In our tomorrow class also, I will provide you with a bit of more information about what is a port in networking, how it works, what is an open port, what is a closed port, what is a port scanner. And as I mentioned, we should be ready to work in our assessment task 2 to write the exact code. So here is the assessment task 2. Let's have a look. Okay, so here is a description of the task. It says that imagine that you are a junior programmer working for a network security company called DigiCore. Your team has been tasked with developing a tool to scan open ports. So as I said, I will have a chat about ports and IP addressing a network. Later on in next year, we have a networking unit, and in the networking unit, we go too deep about what is an IP address, what is subnetting, what is port, and what are protocols, how they perform. But in order to have a better idea about what we are doing in this task, next session I give you a bit of more information about ports, what they mean, and how many ports do we have, how they help us in networking and communication. But at this stage, imagine that we are creating an application or we are writing some codes to help us to scan open ports in a target system. This tool will help to identify potential vulnerabilities and enhance the organization's security posture. The project manager has assigned you to design, code, and test these port scanner scripts. The task summary is to summarize the script requirements, that we will do it in our next session. Document expected benefits, why having a port scanner is useful to improve security. And also here in step 3, you see that it's talking about a pseudocode. It says create a pseudocode or a flowchart. So that's the importance of pseudocode. Why? Because when you don't have a pseudocode, when you have a task and you promptly jump to the Python coding, it's highly possible that you ignore some sections or some functionality might be missing. And if you remember in our previous unit when we've been working on if, loop, and etc., I emphasized multiple times that before jumping to write the code, in your own word, just write down all the main steps. Or even if you want to be in detail, that's totally fine. You can put all the steps. exactly the same way that when you want to, for example, make a cake, sometimes you follow a recipe, but after a while, when you repeat that task again and again and again, it's just like you know what are the steps and don't need to go to a recipe. You don't need to read it from a book or from your phone. It's in your mind. It's just automatically tell you what you need to do. But if it's a new recipe or if it's a new dish, so obviously you need to follow a recipe step by step if you want to get exactly what you saw. For example, um, in a video, you just need to follow all the steps on how to prepare that dish. How much time you need to wait, how much time you need to cook, how much ingredients you need to mix. So on a pseudocode, it's pretty the same, step-by-step procedure. Again, just imagine all the previous activities that we have in our previous unit. Creating, I don't know, a password manager, creating a currency converter, creating a temperature converter, BMI, pizza shop menu, all of the previous activities that we had. Firstly, before jumping to write the code, you say, okay, I want to ask, for example, the size of a pizza. So I need to have a variable to ask for that. In order to ask, then I need to have an input. I need to have a variable to save those answers. Then I need to go and compare if they selected a small size or medium size or large size. So I need to have a comparison, or I need to have some comparative operators. Then if they selected the small size, okay, the price is, should be this. Then I need to multiply it by the number. Then if it's over $100, I need to delete the delivery cost. If it's less than $100, I need to add another $10 for delivery. All of those things. You just need to write it down step by step, or flowchart. In our previous examples also, I show you a couple of activities with a flowchart. If this condition is true, then I need to do that. For example, if tomorrow is rainy, then I need to take an umbrella. If tomorrow is sunny and it's Saturday, then we can go do shopping or something like that, step by step. So create a pseudocode or flowchart for the port scanner that includes input validation for IP addresses and port range, some logic for scanning each port and identifying open ones, handling of successful and failed connection attempts, displaying results to the user and logging them to a profile. Again, you see in the next section, again, it's talking about the pseudocode, talking about create a pseudocode or flowchart for the port scanner. You need to have some comments. So now you know that with the help of a hash, you can provide some comments. So later on, when you go back to your code, you remember what was that. Or if you want to leave some comments for another teammates that you are working on the same project, they can just read your comments. So you need to provide some comments to document the purpose and functionality of each section, and finding errors and debugging the list of the test accesses. And you see that sudo is a part of this assessment task too as well. Okay, let me go back to my board. There. Okay, so now my screen has been shared. Okay, the next section was talking about sudo. When we are talking about planning with pseudocode and user story, let me to put it here. Planning with sudo and user story. Firstly, I start with user story. What is user story? If I want to be very simple, a user story is just a short sentence. A short sentence that describes a feature from the point of a user. Imagine that as a student, you are a user of View Collaborate. Imagine that you are a user of NavBank. Imagine that you are a user of Spotify. Imagine that you are a user of. So from the point of view of you, what do you want to get? There is a sentence which helps us a lot when we want to have a look on the codes or the points or the benefits of creating a code or application. You can say as a, here, I just leave it blank, type of user, as a network administrator, as an student, as a bank customer, as an online shopper. So as a type of user, I want what? A goal. I want so that, and here benefit. So you can just fill those blank sections with some example. As an student, so a type of the user, as a student, I want to, like for example, log in to Video Collaborate so that I can access my course materials. So this is a user story. Why it helps you? Because it clearly and shortly specify what do we want to achieve with writing our code. Imagine our previous unit assessment task, it was asking to create a password manager. So you can say as a user, I want to create a password manager so I can save my credentials. As a cybersecurity expert, I want to add encryption to my codes so that it improves the security or make it unreadable for attackers. So here in this sentence, a user might be a student, it might be a typical user, it might be a user with special needs. Their goal might be logging to a system. Their goal might be checking the results. Their goal might be view the logs. Their goal might be encrypting some plain text. And benefits, access to the content, access to a website, setting up a server, closing some closed ports, scanning open ports. So for the assessment task 2, this sentence also can help you when you want to write the code for the password scanner. You can say as a student, I want to create a port scanner. As a student or as a cybersecurity expert, I want to create a port scanner so that I can scan all open ports to find vulnerability. As a network technician, I want to scan a range of protocols or I want to scan a range of the ports so that I can identify open ports and vulnerable ones. Password strength checker. In one of our activities, we had a password strength checker. So you can say as a security expert, I want to check the strength of my password so I know if they meet their minimum safety requirements or not. So imagine that in our assessment task 2, if I want to write down a user story, you can say as a, so the assessment says that imagine that you're a cybersecurity expert for Digico. So you can say as a cyber expert, I want to scan a range of ports so that I can find open ports, and vulnerabilities. So when you have your goal in this short and simple sentence, it helps you a lot because sometimes there might be a project that you just miss your way. You start with an idea in your mind and you ended up creating something different. Or you start with an idea and then at the end of your code, you see, oh my God, it's completely unrelated code. So you just need to put these like in a banner. So always you can have a look on it. It's designed for this user. So imagine for a password manager, if I say as a cybersecurity expert, or if I say as a housewife, or if I say as an elderly or as a people with disability. So the same things, but with different features. Highly possible that when you create, for example, a product or a code for some specific goods, you need to make it more simple, more interactive, more visual, or if it's designed for a high level IT expert, so probably it needs to have some different features. In our previous unit for the password manager, we just went to the very most basic syntax that was possible, just using loops, conditionals, and functions. But imagine that you want to create a password manager, which is very strong. So not only it enforces the minimum password security, but also it will include encryption, decryptions. Also for the encryptions, it may go and use a very high level advanced encryption algorithm. Still, it's the same product, but for different target markets. So this sentence not only it helps us with the user, but also explicitly it says that what type of features or requirements probably we need to implement in our code. As you see, it defines what the program must do. It keeps your design user focused, and also it guides your coding and testing. So it can help you to know your client. It will help you for a better user focus, and also it guide you through your coding and your testing. So that's user story. The next one, pseudo. Pseudo code. Okay, so that was the first step talking about user and user story. Pseudocode is not the real code. We had a chat about pseudocode in our previous unit. So it's not the real code. It's just like a simple English-like instructions. Describes what your program needs to do. For example, imagine uh, for the port scanner. If you want to write down a pseudocode for your port scanner for your assessment task too, so technically I'm just helping you with potential answers for your assessment task too. You can say, firstly, I need to start. That's the first step. Then I need to ask for a target address. Imagine, for example, in a company, there might be 1500 PCs, servers, and etc. Which one you want to go and check? Do you want to check the whole available PCs and servers or no? You just want to go to one department or you just want to check one single server. So ask for a target address, ask, for example, for a starting port, ask for ending port. So when you have those information, the next step probably is go to check. So you can say for each port from a start to end, what should I do? Check connection. I'm just reading from your assessment task. So my assessment task is open in my other display. It says exactly an explicitly, it says write a pseudocode or flowchart for port scanner, asking for an IP address, asking for port range, logic for scanning each port and identifying open ports. It's in the assessment task summary. Okay, so these are all the steps. Step 1, start. Step 2, ask for a target address or IP. Step 3, ask for a starting port. Step 4, to ask for the ending port. Step 5, for each port from a start to the end to check the connections. Step 6, for example, if connection is successful, to show the port is open, or to print the port is open. If the connection is unsuccessful, so you can say else, or you can say both of them the same, or you can say if connection is unsuccessful, to show the port is closed. And if, for example, 9 and 4, or loop and end. Yes, so this is a port scanner. I just write it in my own word. So in my port scanner, based on the criteria mentioned in the assessment pass 2, firstly, I need to start. For a start, you can print something like this is a port scanner. Then I need to ask for an IP or address, which device you want to check, which device you want to scan. Is it a one single device or is it a range of devices? Then when we know about that, asking about the port number. So as I said, I will talk about ports. There are 65,000 ports. Which port you want to go and check? Do you want to check the first top 100 ports, or do you want to go and check the first 500 ports? What is the beginning and what is the ending port? Asking for each port to start to the end to check if there is connections. If the connection exists, it means the port is open. So to print port is open. If the connection is unsuccessful, it means that there is no connection. To print port is closed. And end if, end for, and end the whole task. So that's a very, very simple example of a pseudocode for your port scanner. When you combine these two, so the first question was a user story, and the second one a pseudocode. So when you have these two, I have user. Let's put it with another column. So I have user story, and I have the pseudocode. What does it mean? When you have these two, it helps you to write a nice and professional code. So user story plus pseudocode, it will create a complete plan. So not only you know who your user, but only you know how to write your code. The user story in simple, your user story it define what and what. So user story it define the what and why. Pseudo it define how. You want to build a property in a fire zone, for example. It's a warehouse. So user story is talking about what type of property. Is it a residential property? Is it a commercial property? Is it a warehouse? Just talking about what and why. And then pseudo, it tells you how. Okay, so if you want to build a property which is a warehouse in a fire zone area, what steps you need to take, what type of materials you need to choose, what type of layout or structure you need to select. If you want to build a residential property in an earthquake zone, like for example, a country in Japan, okay, so it's a residential area. So residential area has some requirements. Then pseudocode tells you how. Imagine in IT or cybersecurity, you want to create a port scanner. You want to create a password manager. You want to create a password checker. You want to create a vulnerability scanner. Okay, so for what type of user, why they need it? Again, you just need to go back to user story and ask that question. As a, who is your user? I want to, what is the goal? And what are the benefits? User, goal, benefit. User, goal, benefit. Who wants to use this? We want to set up websites for the public, so everyone can interact with our websites. Imagine we want to write the codes for a crypto platform. Who is your target? How they want to use this platform to trade crypto, to send and receive cryptos. What are the benefits? I want to set, for example, a website for a client, and my website wants to interact with, let's say, other payments options like Zip Pay or Afterpay. So we need to implement those options in the payment options. Okay, who might be the user of them? Okay, the user is public. It might be a teenager, it might be an adult, it might be. Okay, so it should be easy to follow the instructions in terms of the layout, in terms of graphic, in terms of selecting the color, and also in terms of getting inputs. For example, when we want to set an account, in terms of checking the inputs, for example, if a field is asking to put a mobile phone, it shouldn't accept any letter. If there is a section asking for a name or for a last name, it shouldn't accept any number. If there is a section asking for postcode, in Australia, it should be 4-digit, for example. So all of those things should be features and already considered in your coding. And then pseudocode, obviously, it tells you step by step on how to create such a code. So that's the difference between user story. You can use this as an insight for your assessment task too. The next thing that I want to have a chat is SDLC. Let me switch to PowerPoint presentation. And I can see that you put something in the chat. I will go and have a look. Okay, so that's the pseudocode. Let's move on. User story, as you see, defining script requirements. A user story is a simple, clear description of a feature or functionality from perspective of an end user or customer. What it does, it helps you, the development team, to understand what the user wants to achieve with that application. Again, as you see here, we have that sentence. As a type of user, I want the goal so that the reasons or the benefits. In the right side, you see deploy a server-based information reporting tool. So I want to install a lightweight tool on the server. So periodically it collects and sends back the relevant data. What is the benefit of having such a tool? I can monitor system health and usage metrics in almost near time. It helps me to take a proactive approach for maintenance and decision making. In cybersecurity, we have such a tool. For example, a software like Splunk is a software that is designed for this purpose. It has some forwarder. You can install the forwarders. Imagine in a big organizations like in a university or in a bank. It's a software that you can install it in, let's say 1500 best bank branches across Australia. What they do, they collect all the logs. They collect all the events. They send it to a central dashboard, and the dashboard will analyze all of those information. And it helps the security team to find any unusual activity, any vulnerability that might be available in the branches. And to take a proactive approach towards cybersecurity and decision making before, for example, having type of attacks or before having data breach, so we can find those vulnerabilities. The next topic is talking about SDLC methodologies in secure scripting. Firstly, let me go back to my board and have a chat about what is SDLC or software development lifecycle. Here you see there are 6 stages for software development lifecycle, starting from planning and then going to the requirements, design a software, develop it, test it, and maintain it, and probably retirements of the software. So a software usually goes to this life cycle. Why? Probably having some demands or urgency or requirements that it dictates having that type of software. Then planning, designing, creating the software. Technically, in our Python coding, we are working on a stage 4, which is writing the codes, but it should start from planning. What do we need? Later on in Cert for in cybersecurity, also you will see we will use programming a lot. We don't want to be programmer, as I mentioned at the beginning of this unit. We don't want to be programmer. We just need to know how to use those tools. But later on, if possible, as a penetration tester, we want to go and check the security in a system. If possible, as an IT admin, we want to maintain a big network with thousands of users, with thousands of PCs, printers, IoT devices, network devices, and etc. We want to automate some tasks. We want to scan a big network. We want to analyze logs, all of those things. So, highly possible that we need to design our own products, our own systems. It's possible that some companies they outsource, for example, getting those softwares to a third-party company, but when they want to have a chat with those guys as a IT product seller, we need to talk in their language. We need to have a little bit of familiarity with IT techniques and IT terminologies and also software terminologies, so we can translate our requirements to their words. And when they're talking, also we understand what they mean. So this unit is talking about that, filling the gap between business needs and IT language or programming language. Let me go back to my board and have a chat about software development lifecycle. Okay, software development lifecycle. So what is it? As discussed, it's a step-by-step process. A step by a step process. When we are talking about a software, it might be pretty simple software, or it might be very complex CRM system, for example. It might be a database, it might be a website, it might be a phone application. Doesn't matter. They all follow this step-by-step process. What it does, it help to plan, design, build, and delivery. Exactly the same way that builders, they go and they build a property. So imagine that you have a piece of land and you want to build your own property. So first of all, it's required to go and have a chat with a planner or an architect. So what they do, the architect, they ask you some questions. How many rooms do you want to have? Do you want to have your kitchen here or there? Do you want to have a double story? Obviously, you just need to tell them how much is the size of your land. They have some obligations and laws and requirements. For example, council tells them the maximum size of the property should be like 50 or 60% of the size of the land, all of those things. But it's a first step to have a chat with an architect. You say, I want to have my property like this, the material, design, layout, all of those things. Then they take some time, they create a plan for you, and they send it to you. If you approve the plan, if you're happy with that design, then they pass that plan to the builders. Then builders start. For example, if there was already a property there, probably the first step is to move waste and destroy the old property, taking and removing the wastes. Scaffolding they need to come, then carpentry, plumbers, electricians, all of those things. Later on in our networking unit, we will see the same things. We will see that when we want to build a network for a customer, we need to ask some questions about the budget, about the number of users, if they want to have a wireless network, if they want to have a cabled network, how many routers do they want to have, how many switches, all of those things. Firstly, to discuss with the clients what are the requirements. So this is the first step, planning. Then to design exactly the same way when we create a network, when we are building a property. So in case of property, you just need to have a plan. Architectures will help you. For a software also, it's the same. Imagine a client is asking for a website. A client is asking for um, an application, a database. All of those things that start with a user story, checking the requirements, planning, designing, then building. In case of property, builders, they start the job. Plumbers, carpentry, scaffolding, all of those. In a website also, it's the same. You may have front-end developers, back-end developers. So the front-end developers, they go and they create the main page that it interacts with the user. So when you go and visit a website like Westbank, Office Book, JB Hi-Fi, that website has been designed by front-end developers. For example, they decide about the logo, the color, the layout, the font. For example, to have a dynamic website, so you see that some photos are coming and moving. And also we have backend developers. So they write the code for the backend. Backend might be, for example, the web server. It might be the database. It might be the web server, which keeps all of those files, and just like that. And eventually you will deliver the projects. Probably the next step is to test it, make sure that the website is fine, make sure that all the functions are working, make sure then to deliver it. Also, a software may have a life cycle. After a while, it's possible that that website is not in use anymore or that application is not in use anymore. It needs to be upgraded or sometimes it goes to retirement. So by using this SDLC, we can be more organized. We can predict what happens in the next step. It reduces the risk. It's much easier to manage the projects, and it's specifically designed for our user requirements. There are a couple of steps in SDLC. So if I put it down, I can say SDLC phases. And then after this, I will have a chat about some methodologies like waterfall and agile. The first step, as discussed, it's planning. In this step, you will ask about the problem. Imagine we write some codes. We write a code for currency conversions, temperature conversion, BMI calculator, tax calculator, menu, pizza shop menu, all of those things. So what problem this code is going to help or to solve? What the user need. So you can have a chat with the users. You can write user stories. You can have a chat with users. You can define the system features. You can define the project goals. It all goes to this first step. For example, imagine a school is looking for a student login system. So it should be simple. Probably it's because it's for a school, high school or primary school. So it needs to have simplicity. Username, password, also sections and fields. They need to be pretty big probably. It needs to get and take input validations. The system needs to check authenticity. It should show a short dashboard if the login was successful or not. So this is the first step. The second step after planning, it usually is analysis. This is usually the second step. How will the system work? What type of data probably we need to have? What are the inputs? What are the outputs? What is the data structure? Are we working with strings, numbers? What it should be the outcome? What are the limitations? Like cost, like time, like technology. Sometimes the customer is asking for software, but the software doesn't match with their current system. Later on, when we go to our cloud unit, we will see this. Sometimes the customers are asking to transfer part of their data to a cloud environment, but their system is not compatible. Sometimes they want to have an application, but that application is not compatible with their current systems. So this is the second step, analysis. Exactly the same way when someone wants to build a property in an earthquake area or in a fire zone area, just to analyze all the possible information, time, technology, cost, everything. So we collect as much as possible information and then we analyze it. Then we design. When we are designing, we can use flowcharts, we can use pseudocode, you can use database diagrams. Imagine for the port scanner, I write it down here, all the steps in a pseudocode. So you can write it down that way, or you can create a pseudo chart. You can create a diagram. So you design it. For the portal scanner, you design. For the password manager in our previous unit, you design. You said that I have a menu. In my menu, there are three items. The first item is asking for credentials. The second one to view this credentials. The third one to exit. Then also I need to have a TXT file. My username and password should be saved in a TXT file if there is one. If there is not, then the system should create a TXT file and save all the data. And then when I want to see my all credentials, it has an option to show me. So that's the design. The next step when you design your code is development. Okay, so when you know about your design, sometimes customer might be responsible for all other steps, but for development, they can ask another business, another third-party company to help them to develop such a product or such a tool. It's very common, but obviously we need to have all of those other steps completed so we know what we want. When you know what you want, even if you want to outsource it to someone else, it helps not only you, it helps your third-party developer as well. You have a clear idea of what you want, so you can inform them about your requirements, your limitations, and it helps them to quickly develop that software. So this step is the actual development step. In the previous sessions, we had a chat about some programming language like PHP, Ruby, Swift, and etc. They all designed for different purposes. So in development step, I can say it's coding step. It's a developer that they decide which programming language might be the best option. Is it better to use Python, or is it better to use C Sharp, or is it better to use JavaScript? They all have their own features. Then testing, just to make sure that the code is working as expected. Sometimes companies, like for example, if you have a banking application on your phone, they tell you that from midnight till 4 o'clock in the morning, the application is not accessible. Why? Because they do an update or they redesign or they are testing. So it's not publicly available in that period of time. From midnight till 4 o'clock in the morning, they go to this whole process. It's very common for IT jobs that they have night shifts working from midnight till early in the morning just to do a backup, just to update the systems, troubleshooting, testing, because usually in that point of time, they have low traffic and it doesn't interrupt the whole business traffic. So they go and test to make sure that software is working. It's still possible that they go to a heavy testing, but having some issues, vulnerability problems, or having some bugs even after the release. Still, it's possible to have some bugs or issues. So then it goes to a system test, testing the whole program, testing the small pieces of the code, user test, security testing, all of those things. And eventually deployment. So at this step, when testing is fine, they go and deploy that software. They publish the app to Google Play. They publish it to App Store. The website comes up. It installs a system in a company. It makes live. So they deploy that software. Then it goes to real testing. Customers will interact. It might be some bugs. So usually in the first days of deployment, the whole IT teams are alerts if there is any issue to quickly go and fix it to avoid any interruptions. And if everything goes well, then maintenance. Maintenance. And in this step, which is usually the last step, fixing bugs, adding some features, making it nicer, changing the graphic user interface, updating the security, making it more smooth, updating the policies, patching vulnerabilities, all of those things. It goes to maintenance and a possible of a retirement as well. So these are the main steps in software development life cycle. So 1, 2, 3, 4, 5, 6, and 7. Planning, analyzing, design, development, test, deployment, maintenance, and retirements. Let me go back to my PowerPoint presentation, and then I have a video as well, which I show you. Okay, so you see that what I had in my board is here as well. Planning, requirements, and analyzing. It put it in the stage 1. Defining the requirements, design, development, testing, deployment, and maintenance. They are the main sections in a software development life cycle. As you see, it starts with defining the projects. Project is a web browser. Project is a fitness application. Project is a portal scanner, a password manager. Project is a data analyzer. Okay, then talking about the requirements, technical requirements in terms of what type of hardware, software, compatibility, functional requirements, what it needs to do, designing your software. I will talk more about the design, development, coding your software with different programming language, version control, standards, testing, manual testing with a human. A human goes and interacts with the system to make sure that it's working, or an automated testing. And eventually deployment. So if everything goes well, then in the next step, the software can go live. If it's an update, it goes live. If it's a website, it comes up and it's accessible for the public, maintenance and feedback. Here in the next step, you can see that there is a project manager, there are developers, there are vulnerability scanner, security tester, deployment, maintenance, and you see that in big projects, there might be different groups working on the same task. Imagine it's an application, so that application has so many sections. One group might be responsible for user input. For example, setting up the database, creating the fields for username, for the password, for input validation, for managing that part. Another team, they might be responsible for the structure. Another team, they might be responsible for security. Another team, they might be responsible for vulnerability. Another team, they might be responsible for API and compatibility with other systems. And they all work with each other just to make sure that an operating systems or a software It's all good to go. There are a couple of methodologies for a software. You just see a few of them. On the top, you see waterfall model. And you see it says it has a linear structure and it has security testing in each stage. Also, you see agile methodology, continuous integration with regular updates, automated security tools. You have DevSecOps, development, security, and operation. We have a spiral model, which is something between waterfall and agile. And you have V model. With the DevSecOps, it has a good integration with security pipeline, collaboration between development, security, and operation team. So developments is the developers. They have knowledge and skills in programming language. Security, the experts in security area. They know about the security standards, protocols, ports, and etc. And operation, they are responsible for live operation of the software. We do also have a spiral model. As discussed, it's something between waterfall and agile. I will go through waterfall and agile in more in depth. Spiral, iterative development processes and risk analysis and security focus on each phase, and V model, validation focus on testing functionality and verification ensure security requirements are met. Let's have a look on waterfall model and agile. As you see in the next slide, the waterfall model is a sequential approach in which each phase must be completed before proceeding to the next step. It's linear, systematic, and it's more suitable for projects with well-defined requirements. The advantage of using waterfall is it's easy to manage, it's understandable, and it's suitable for projects with stable and well-understood requirements. The disadvantage of waterfall, however, limited flexibility, difficult to adapt to changes. Late discovery of issues may lead to high cost. And also testing occurs at the end, increasing the risk of unresolved vulnerability. What it means when we are talking about waterfall approach. Let me go back to my board and explain this in more detail. Right switch. To start, just give me a sec to make my note full screen. Yes, all good. What is waterfall approach? As you saw in the presentation, it was talking about waterfall as a linear systematic approach. But what does it mean? In a waterfall approach, it means you need to follow an already set plan. It's usually suitable for situations with minimal changes. For example, imagine in an ATM machine. Imagine in a traffic light. It has a set procedure. For example, in an ATM machine, it works like this. A card will be inserted, then it will ask for a password. After approving the password and after making sure the card is original, then to ask if the user wants to withdraw, if they want to pay for a bill or something. It's always used to be that way, and it's possible that for the next forecastable future, it's still follow the same process and procedure. In a traffic light, so it goes to green, after a few seconds it changed to orange, then it changed to red. It has a systematic approach. It doesn't need, for example, to change from orange to purple or from orange to blue. No, from orange it goes to red. It has a systematic approach. Usually for situations like for government agencies or for military, they have a systematic approach. They have a well-defined step-by-step procedure. It's highly possible they don't need to do a quick change or doing a quick shift in the software. So everything has already discussed, everything has already detailed, it's already agreed, and then they can go to the software development process. Everything is pretty forecastable, predictable. It doesn't have any quick or significant change. So I can say this process is a linear, a step-by-step software development model. For example, in a website like ATO, Australian Taxation Office, or Centrelink, a highly possible if they want to have a change in their website, it needs to go to an intense process. Probably they spend a couple of months on talking about the requirements, planning, designing, and then developing the changes, then testing, and then it goes to the deployment. So the process is very rigid, tough, in detail. Obviously, after each step, they need to confirm it, make sure everything is fine. Why? Because of security issues, because it impacts a large number of people, probably in a banking system as well. So ATO, Centrelink, banking system, when they want to have some features in their websites or in their applications, it usually follow the waterfall model. A step-by-step, systematic, well-detailed, approved, agreed. Obviously, if there might be a change in the system, it takes time. The procedure is so heavy, which doesn't allow any quick shift. It might be a disadvantage anyway, because the system is not fast enough, it's not agile, but it has its own feature as well. It's more secure, it's more predictable. So it reduces the having of interruptions. It reduces having the systems being out of access. So I can say in this model, it has fixed requirements, heavy documentation. They have meetings after meeting. It's the case. Imagine that later on you get a job in IT, in a penetration testing, in a software development. So usually they go meeting to meeting, meeting to meeting. In each meeting, they are talking about their requirements, heavy documentation. Planning is done at the start. It doesn't mean that they always follow the plan. For example, this Sunday, there was a Westgate Tunnel opening day, and it was forecasted it will be ready like 2 years ago. They planned for it, meetings, documentation. So imagine a project like Westgate Tunnel. It went to the process of waterfall. Everything was already planned. It doesn't mean that they stay and stuck with the plan. No, but they have it at least on the papers. If there is any change, again, it needs to go to an approval, so many people, they need to confirm, budgeting, timing, all of those things. So it has little room for change. Imagine they started the project and then there might be some new situations that impacts the whole project. It's not easy to go and change it. Everything is clear. These are the features of waterfall, as discussed usually for government projects. Sometimes even it might be not a government project, but the client is asking for an understandable, planned, structured software. Okay, so it has its own advantage as discussed. Banking systems, finance systems, military, aviation, medical systems, that they have a systematic approach. They usually like this. And I give you some examples like in an ATM machine, like in a traffic light, like a student management systems. For example, here in VU Collaborate, it follows a systematic approach. So you go to the enrollments, then you have class attendance, then you submit your assignments, then you will be marked, results, and final graduations. In the other side, we have Agile. So the name explains itself. Sometimes you need to be very quick. There are some changes that we need to take quick action. So obviously following the waterfall approach is not suitable. We need to have a quick, agile approach. What is agile? In an agile approach, instead of considering the project as a whole, it has iterative or repetitive approach. And what it does, it breaks down the whole project into multiple small pieces. Software breakdown in a small pieces. So if there is an issue in each section, it can quickly go and be fixed. It doesn't need to change the whole code. It doesn't need to change the whole system. So it breaks down the whole project into multiple small pieces and improved continuously, probably based on the user feedback. Imagine in a website, like for example, a website for Amazon, for eBay, for Kogan. So imagine in these next 2 months, there are heaps of events. They have Black Fridays, they have Boxing Day, they want to quickly update their websites. For example, having a banner showing that there are 25% discount, changing the layout, putting some new items. So if they want to go to a whatever process, they miss the time. They need to go to the meetings, approving, agreeing, documentation, but they need to be very quick. There might be some occasions next 2 weeks, so we need to update the whole appearance in the main page. Still, the backend is the same, the database is the same, but we need to change this section of our website to make it more interactive, to provide enough space for our promotions, for example. So obviously, when they have the websites already break down into multiple pieces, they don't need to go and change the whole system. No, just the interface goes and change. Just the database can be adjusted. Promotion sections can be added. Layout can be changed. For example, having a new color or having a new logo. It's Halloween, for example. So we don't need to go and start everything from scratch. We just can go and add some funny moving items just to show that it's pretty close to Halloween. Something like that. In this approach, it has short development cycle, like 1 to 4 weeks for different events, for different occasions. Continuous feedback, checking if the user checking, they have data analytics. They do some changes in their websites and then they compare the results. How many clicks they had in the last 2 weeks after updating the website to its new version. They can have a look on the sales, they can have a look on the number of clicks, they can have a look on website traffic, and based on that, based on the users' feedback, they can go and improve. Easy to change. So they can be quickly changed because it's just hundreds of small pieces. It's very quick. It's very quick. It needs weekly or sometimes daily. Weekly or daily. Team meeting. So it's possible that you get a job in AWS, you get a job in Azure, Microsoft Azure, you get a job um, in these kind of companies. They have daily meeting. Every day they have meeting. At 9 o'clock, every day they have a stand-up meeting. They're talking about what we want to do at the end of this week. So for example, development teams, you're responsible for that. Security team, you're responsible for that. Database team, you're responsible for that. They have short meetings, weekly or daily sometimes. And it's very useful for mobile applications, for websites, retail websites, for startups, for example, for machine learning projects. Every day now with the improvements in AI, you see even big websites that are changing weekly. Anything which requires quick shift and quick change, it should go and follow the agile approach. Let me show you. Let me go back to the presentation and then I show you a video. And then I will also have a look on your chat. So that's waterfall, as you see. It's easy to manage, but it's difficult to adapt to changes. It's pretty heavy and slow. It has heavy documentation and it's follow a systematic approach. And the other side, we have agile model, which is an iterative approach emphasized on collaboration. It's flexible and it's improved based on continuous feedback. So a project will divide it to smaller pieces or sprints or cycles, and it encourages rapid adaptation to change and continuous improvement. The advantage is it's very fast. If there are some new changes, competitors, for example, they take a new approach. There are some sudden changes, economical changes, for example. There might be some trade wars or um, commodity price or oil price goes up. There might be some new events. So we need to quickly reflect those changes in our product. Agile profile and agile approach really helps to automatically and quickly detect and resolve issues in the earliest stage. The disadvantage, it requires significant involvement from different stakeholders. So as you see, dev team, operation team, product owner, product developer, they all need to be in dynamic and constant communication. Probably they are not able to go to a formal process of documentation. As you see, documentation may be less comprehensive and can become chaotic without proper management. So there should be a good management on the agile approach. Okay, so that's on this PowerPoint presentation. Let me also to show you a video about this. Sorry that I have a bit of flu as well and I lost my voice. Yes, I found it. Let me share my screen.
He is interested in hosting an online store for home decor products like vases, curtains, artwork, and home furnishings. He requires a software application that would allow the customers to browse the available products at their fingertips and buy them online. Adam, eager to jump into his new business, wanted to understand how the software development process works. To start with his business idea, Adam meets his cousin Mark, who is a software developer and a good one at it. He pitches his idea and asks his cousin to help him design an online business application. Mark explains to Adam the way of designing the best online shopping application. We need to understand the working of the software development lifecycle, also known as the SDLC. It involves distinctive phases to initiate the software production based on the client requirements. Further, Mark briefs Adam about the 6 crucial phases of SDLC in designing any software application: planning requirements phase, requirement analysis phase, designing phase, implementation phase, testing phase, deployment and maintenance phase. The development team will commence production post agreeing on the terms and conditions discussed between the client and the development team regarding all the proceedings and requirements. Initiating the production with the planning requirements phase, where the client and the development team will discuss the basic requirements for the software, like the purpose of the application, the details about the end user of the product, key elements like format and attributes of the application for designing, and the overall user interfaces design of the software. The development moves on to the second stage, the requirement analysis phase, which includes the detailed information about each element to design the software as discussed, validating the installation of elements in the application according to the client's requirements, calibrating the security protocols, and performing risk analysis for the software application. All the discussed details are then to be filed in the Software Requirements Specification document, also known as the SRS document. After completing the second phase, third stage of software development, the design phase, the software designers will devise the system design following the SRS document. The system design defines the overall architecture of the software and checks its feasibility with the client's requirements. All the details of the design phase are added to the design document specification, also known as the DDS document, and shared with the analysts and stakeholders for review. Next, the development moves on to the fourth stage, the coding or implementation phase. In the coding phase, the developers start writing the code using the languages they choose for the software development. The coding stage is also one of the most important phases as it encapsulates the implementation of the software product. The developers use predefined guidelines and development tools like compilers and debuggers to implement the code. The next phase of the production is where we begin with the fifth stage of software development, the testing phase. The developed software is now deployed in multiple test environments to check the functioning of all the attributes in the software architecture. After the test cases are completed, the quality assurance and the testing team may find errors or bugs in the software, which will be forwarded to the developer team for debugging. This testing and debugging process continues until the software is stable and works per the required specifications. As for the last stage in the SDLC lifecycle, the deployment and maintenance phase is initiated. With the testing phase completed, the software application is ready for deployment and consumer use. In this phase, the development team will set up links for the application and make it accessible to the users. After the deployment is completed and users begin using the application, they may encounter an error or a bug in the application, which is to be solved from time to time. Maintenance also includes releasing application updates and enhancements for the software for better performance and user experience. Adam, at this point, was surprised by all the effort and steps taken by the development team to design a software application and the key phases involved in SDLC. And on that note, here's a question for you all. What does the design document specification document include? Software code, details on defects and bugs, software architecture details, software requirements. Give it a thought and leave your answers in the comments section below. 3 lucky winners will receive Amazon gift vouchers. With Mark's explanation of the
Okay, so I hope that you enjoyed this video as well, which was talking about the SDLC. Regarding the questions that you put in the chat, Mike already provided you with the link that he created in WhatsApp, so I reckon it's good to have your group of your classmates. Thank you so much to Mike. Also asking about the having waterfall and agile as static and dynamic. Yeah, it's pretty good analogy, but also the waterfall is not fully static. It changed, but it's so slow. It's just like, for example, comparing a rabbit and a snail. So a snail also is moving, but it's not that fast. Also for the port scanner, yes, if you want to give it a try, you can try 3 libraries. Let me share my screen. There are 3 libraries that you can use for your assessment task too. If you want to go and test it before our class, you can use these libraries. Let me share my screen. One of the best libraries that you can import is Socket, Python library. So Socket is one of the best one for that purpose if you want to go and try. The other one is Scapy. In Search for in Cybersecurity, we'll learn more about each of these libraries for different purposes, but if you are curious to give it a test, Escapee also, it's another library that you can import, and in the previous sessions, we have a brief chat about how to import a library. If you remember, I imported a library for time, I imported a library for mathematics, I imported a library for what else? Time, mathematics, operating system. So yeah, that's another library. And also we have another one which is very, very famous. It's Nmap. Nmap library for Python. Nmap stands for network mapping. Uh, Not in this year, but in our first time in 2026, we have 2 units working with networks and working with PCs. We will use Nmap a lot. It's a very useful tool for network troubleshootings and also to collect information on big networks. There are some other libraries as well that we don't use it, but Moscon also. Network scanner. And yes, Nmap Escapee and Nmap Escapee and Socket. So Socket as well. Socket, I reckon it's the best one for this task. Socket Python library. Low-level networking interface. If you just have a look on this website, it gives you a bit of more information. So the website is docs.python.org. And then here it says this module provides access to the BSD socket interface. It's available on all modern Unix system, Windows, Mac OS, and probably additional platforms. What it does, it doesn't work or it's not available on WebAssembly. And yes, all the information and how to use it and the syntax and etc. So socket, just have a look on this socket library. We go through it anyway in the next 2 sessions. And what else? Yeah, if you just import socket, then all the other codes should be pretty easy and straightforward. You just need to use loop, if. Before that, I give you also a bit of more information about what is port, how many ports do we have, and what is a port scanning. Cool. So let me to also quickly update the attendance.